Hello, ladies and gentlemen. Today we're looking at how to show lines are parallel. Another name for show is prove. Okay, so we've got some keywords here: converse, hypothesis, conclusion. Hopefully you guys remember those from a few weeks ago. Okay, it hasn't been too long. So suppose you have two lines that are cut by a transversal so that the corresponding angles are congruent. What could you say about the lines? Well, here's the key. Corresponding angles are congruent. In the last lesson we learned that if we had parallel lines, then the corresponding angles had to be congruent. So here we're actually switching it. We know this part first. Okay, so what do you think? If we already know that our corresponding angles are congruent, could we say that the lines are parallel? We should be able to. Okay, so do you remember if-then statements and their converse? We're going to talk about that a lot today. So here's just a reminder. If you go to work, then you earn a paycheck. So go to work would be your hypothesis, earn the paycheck would be your conclusion. These are the things that we underlined and we circled, if you remember doing that lesson. So then our converse, we're going to switch the hypothesis and the conclusion and see if you still have a true statement. So for this, our converse would be if you earn a paycheck, then you go to work. And remember, the if is what's first, then is what's second. So this would mean that you've earned a paycheck and now you're going to go to work. That could happen. So think about this one. Now it actually applies to our geometry stuff. So if angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. Okay, so if we're going to do the converse, we're going to switch that. So that would be if angle 1 is congruent to angle 2, then angle 1 and angle 2 are right angles. So think about that for a second. Are all congruent angles, angle 1 and angle 2 are congruent, are all congruent angles also right angles? Do they have to equal 90 degrees in order to be congruent? No. So this is not true. When we switch the if and the then, sometimes it's not true, sometimes it is true. Okay, so let's think about this. The corresponding angles converse. If corresponding angles are congruent, then the lines are parallel. Do you think that would be true? If we already know that these two angles right here, angle 1 and angle 5, are congruent, could we then say that these have to be running in exactly the same direction so that they never intersect? Yes. This is a converse that is true. Okay? And it's all about what you know first and what you know second. All right? Okay, so here's how we would apply it. Is there enough information given to conclude that line BD is parallel to line EG? So here's our two lines, BD and EG, 110, 110. Those are corresponding angles. So we would say yes, and then our reason would be corresponding angles are congruent, therefore parallel lines. And that would be it. How about this one here, letter B? On this, all we know is this 60 degrees. We don't know anything here. K-N-O-W. Know nothing. So therefore, what we would write is no. We know nothing about the other intersection. Oops, section. Sorry. Intersection was too long, I guess. Okay, so here's two more theorems that say basically the same thing. But it's what we did last time. Everything's just switched as far as the order in which we know it. So now the alternate interior angles converse. So if alternate interior angles are congruent, then the lines are parallel. Okay, then the lines are parallel. Alternate exterior angles. Before, we said that if we have parallel lines, then the alternate exterior angles are congruent. Now we just switch that. if alternate exterior angles are congruent, sorry, happens with exterior and interior, then the lines are parallel. Okay, so right here, if we have this picture with angle 1 and angle 8 marked in this way, we should be able to put nice, pretty, parallel line markings on R and S to show that they're parallel. Okay, so here's an example that uses that. On letter A, do we have enough information to say that M is parallel to N? We would say yes. Alternate interior angles are congruent, therefore parallel lines. B, we only know information at this intersection over here. Okay, we don't know anything about this intersection where M is intersecting with T, so we're going to have to say no. We know nothing about the second intersection. And you could abbreviate intersection with INT. Okay. All right here, same side interior angles converse. So before we said if you had parallel lines, then same side interior angles are supplementary. So here we just reverse that. So if same side interior angles are supplementary, then the lines are parallel. Oh, I forgot to put up our shorthand, didn't I? So your shorthand for that would be SS interior angles supplementary, therefore parallel lines. Okay, and for this one, this is a little bit different than the others because we actually have to know what the angle measures are here. Okay, on the other ones we were able to just put arcs, like we had two lines and we said, oh, this one is equal to that one. That's fine with the two arcs, but here we have to know the angle measures because just because they're different, let's say that you have this one marked with a single and then this one down here marked with a double. Different doesn't mean supplementary. These could be, 50 degrees and maybe 110. And if this is 50 and 110, then these lines are not parallel because 50 plus 110 does not equal 180. Okay, so on these, let's see, so here we have to know each angle measure. That is a key. Okay, these simple marks aren't going to help us out very much. Okay? All right, so right here we have an application of that one. So find the value of x so that j is parallel to k. All right, so right here we want j and k to be parallel. We want to be able to put those little arrows in. So in order for that to happen, again, first decide what kind of angles you have. These are same side interior angles. And the rule said that for same side interior angles, if you have same side interior angles and you want the lines are parallel, then those had to be supplementary. So right now, everything I'm writing down is just my thoughts of how I'm going to figure this out. So now I can go ahead and start working. I go, oh yeah, it has to be supplementary. So now I can say that 115 plus 5x would have to be equal to 180 in order for j to be parallel to k. Does that make sense? Okay, you wouldn't need to write that. Don't have to write. But that is your thought process. Okay, so now you can solve. So you would subtract 115, work on our algebra skills here. That's 5x equals, what would that be? 65 degrees. And then divide by 5. So x would be equal to 13. Okay? Okay, so all of the other converse formulas, you would do the same thing. If it said, find the value of x so that j is parallel to k, first you want to figure out your angle relationship. First, this part, angle relationship. And then decide if they're supplementary or if they're congruent to each other, and then set up your equation accordingly. So 3 would be set up equation to solve. And then, of course, you would solve for the last step. Find variable. And then always, 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 finally, make sure that it makes sense. Just ask yourself that question. Does what I did make sense? Okay. All right, that's it for today, ladies and gentlemen. Get started on your WSQ for section 3.5. Thank you.